All right there, Chem Scholars. We have one question to review on the idea of combustion analysis. So the very last two questions in the packet under part 4, number 3 and 4, give them a try, but I'm going to go through the explanation now. So if you don't want to hear the explanation yet, hit pause. Pretty simple, right? Okay, so let's bring this around. Turn this around. All right, so there are the questions. We have 5 grams of an oxyhydrocarbon producing 7.33 grams, let me move my mug out of the way, of carbon dioxide and 3 grams of water vapor. And what is its empirical formula? All right, so we're going to start just like we did with carbon dioxide, but as a reminder, okay, when we talk about carbon dioxide, CO2, okay, it's made of 1 carbon, 2 oxygens. Carbon has a molar mass of 12 grams per mole. Oxygen has a molar mass of 16. So carbon contributes 12. Oxygen contributes 32 for a total of 44. So that means that carbon is 12 out of every 44. So we have 7.33 grams of carbon dioxide. And we know that carbon is 12 grams for every 44 grams of CO2. All right, so now I just multiply and divide that. I get about 2 grams. I'm going to go an extra decimal place for a moment and say 1.99 grams of carbon. All right, now we got to take care of water. So same analysis. Water is made of 2 hydrogens, 1 oxygen. Hydrogens are about 1.0. Oxygens are about 16. So that's 2 and 16 for a total of 18, right? So that means that hydrogen is 2 out of every 18. So when we talk about water, which we have 3 grams of water vapor, we know that there are 2 grams of hydrogen for every 18 grams of water. Now again, you could simplify that down if you want. Let the calculator do it, is my thought. So now we just, again, multiply and divide, and we get around 0.333 grams of hydrogen. All right, so now we have to take care of oxygen. But we know this compound has 5 grams total. We know that there is 1.999 grams of carbon. We know that there's 0.333 grams of hydrogen. So everything left has to be oxygen since it's an oxyhydrocarbon. So I subtract it out, I get around 2.667 grams of oxygen. All right, so now when we're doing empirical formula, I really wish I had a little bit more space here, but we'll manage. We take the masses of each, so 1.99 grams of carbon, 0.333 grams of hydrogen, and I'm going to bump my work down just below the line here to the 2.667 grams of oxygen. Carbon's molar mass is 12, hydrogen's is 1, oxygen's is 16. All right, so we end up with around 0.167 moles of carbon, 0.333 moles of hydrogen, and 0.167 moles of oxygen. Last step, simplify the ratio, so we divide by the smallest number, which happens to be about 0.167, and we get a ratio of 1 to 2 to 1, making our empirical formula CH2O. And now this is a callback to the previous unit where we talked about molecular formula. So when we want to find the molecular formula, we need to know the empirical formula. We need to know the molar mass of the actual compound. So first thing we're going to do is figure out the molar mass of the empirical formula. So we're going to take C plus 2 H's plus O, that's 12, plus 2 times 1, plus 16. That adds up to be 30 grams per mole. The actual is 180, We divide that by 30 to see that we're off by a factor of 6, making our MOFO C6H12O6. Good old glucose. All right, let me know if you have any questions, but that's it. That completes the first part of this unit. We're going to have homework due Monday and assessment on Tuesday. All right, people. Talk to you soon. Bye.